Hello everyone, welcome to Ieee Xpert. So today we are going to see project about respiratory disease classification using lung sound. So this is the project which we are going to discuss about today. So this project published on IEEE Transaction Journal, which is recent year 2023. You can see the dates also. It's a 2023 year. Okay, this project completely innovative project. So the overall aim and concept of the project was we have to identify various lung related diseases using the lung sound, respiratory sounds. What's the meaning of lung sound or respiratory sound means? If you are going to the doctor for a specific disease means, first of all what doctor will do means they will place the stethoscope on your lung part. They will hear your respiratory sound. Okay, your breath sound, they will hear your breath sound. From the sound itself they come to know about the specific disease. That's what each and every doctor will do. But the major problem here was the stethoscope can't be able to reproduce all the sound which is belong to your lung part. The doctor won't hear exactly. That is the major drawback of this project. You won't hear the complete sound part. This is the major drawback. So what we are going to do means we are going to design a machine learning framework. What the machine learning framework will do means it will recognize all the sounds. So what the machine learning algorithm will do means it will classify each and every sound into the specific disease category. That's what it will do. Okay. In this project, we are going to do that only. Okay. To implement this project, the major part was the collection of data set. We have to collect various data set of each and every patients. Okay. Different lung sound of each and every patient. That's what we are going to do. We have to collect various disease sounds also. For example, you can see these are the disease names. Okay, for example, pneumonia, then healthy sound, coronary lung sound, then lung infection signals. Okay, then uh, then bron URTI. These are the sounds which we are going to extract from the patients. These are the sounds which you are going to extract from the patient. So these already collected data set available for the projects. You can find the data set named as a biomedical health information data set 2017. There are various patients, various disease lung sounds are already available. So, okay, we have to take that data set as an example for this project. We are not only going to consider the complete data set. What we are going to do means we have to add some more part with this project, some more part with the data set. We have to form the completely new data set from the existing data set. That's what we are going to do. Okay. Then after collecting the database, what we are going to do means we have to create a machine learning part to classify, pre-processing, then feature extraction. Okay. So first of all, we are going to explain the project PPT for you. So this is the project PPT I'm going to explain today. So this is the project PPT. I will directly explain to you. So this is the project respiratory disease classification using lung sound with CNN and LSTM. This CNN and LSTM was completely proposed system which is not available in the paper. In the paper they have taken Inception network as a proposed system, but in our proposed system we are going to take CNN and LSTM as our proposed system. So that Inception completely belongs to the existing now. So we are going to take the CNN and LSTM as a proposed part. The main motivation of the project was to classify the lung sound based on the different features. Different features means the lung sound features. Based on the features, we have to classify the disease present in the lung sound. The major abstract of the project given here. So to overcome the, to analyze the respiratory sound, we have to develop a completely cost-effective algorithm to be used with any type of disease. So you don't need any higher end devices, higher end processor like that. It can be performed with any type of devices. That's what our main motto of this project. We are going to do CNN LSTM as our proposed algorithm. We are going to extract two type of features. One is GTCC features, another one is STFC features. Those are the features we are going to extract from the lung sound. Those are the features we are going to extract from the lung sound. Okay. So to overcome the existing system accuracy issues, we have to combine two algorithms here, LSTM as well as CNN for the better performance. Okay, these are the things we are going to do here. The introduction given here. The overall lung disease was major problem in current days, okay, which is causing for the pneumonia, tuberculosis, pulmonary diseases. Those are the diseases are identified using exact lung sound only. Before going for the X-ray, this lung sound will give you the clear-cut idea of what type of disease you are having. So this is the major project for this. Okay, we have to record your lung sound. By using the recorded sound, we have to design a specific machine learning part to recognize what type of disease you are having from the lung sound. Okay, so literatures are also given for this project. We have taken existing papers. What are the major drawback in the existing system? Everything given as a literature survey. We have taken around 10 literatures given everything here. Okay, literature surveys. Then existing system, we are giving existing system also. So your purchasing means we will give the complete project for you. In existing system, this is the paper we are classified as existing system. In the paper, they have used MFCC feature extraction as well as inception network as their proposed system. That means the existing system. Okay, the MFCC feature extractor as well as the inception network was very much poor performance. They will perform very poorly while giving for the higher data set. That is the major drawback here. You can find the problem means it's require higher computation time, higher system usage. You need higher system to perform the operation, as well as you need higher time to recognize the features. As well as if you're going for the MFCC feature means it will lead to loss many type of features from the sound signal which you are giving, which is lead to low accuracy. Okay, also you are developing a inception based algorithm na, that also very complex algorithm when compared to the our proposed algorithm. Okay, so to overcome the problems present in the paper, we are going to do the completely proposed algorithms. In proposed algorithm which I mentioned earlier, we are going to implement completely CNN and LSTM based algorithm. Okay, CNN and LSTM based algorithm. It will comes under machine learning as well as deep learning part. That is the major advantage here. We are going to implement this algorithm comes under machine learning and deep learning part by using the lung sound, which we are going to predict the various disease symptoms. The proposed system, as I mentioned earlier, two algorithms you are using, CNN and LSTM. So the proposed algorithm will classify 7 type of respiratory diseases which is available in the data set. This is the data set we are going to do, this data set. Okay, also we are going to estimate accuracy, precision, recall. Those are the things from our database. So I am going to explain the system architecture. You are giving lung sound means this is the signal. Lung sound means you will get the frequency type of signals. Lung sound signal means what it will do means it will resample the signal into 4 kilohertz. It will sample the signal. After sample generation, it will go for the pre-processing. What pre-processing will do means it will extract the particular features, noises from the signal which you are given. Temporal snippet generation means it will generate the reference point from your lung signal. Okay, it will generate the reference point. Then DFT based wander removal, which is linked to noise removal. Obviously, you are recording some sound using stethoscope means there is some type of noises. For example, fan sound, horn sound, or speed sound like that. Some type of noises are there. It will remove those noises. Then amplitude normalization. What it will do means it will boost the signal. For example, if you are giving low quality sound means it will enhance the sound into higher quality. That's what it will do. Then what we are going to do means we are going to extract the features MEL spectrogram using GTCC STFC. Those feature extractor we are going to use. From this speech signal we are going to extract the features. Then those features are trained under CNN and LSTM for the overall classification. There it will produce the accuracy, loss ratio and everything. Then final classification you will get asthma, COPD, health disease or pneumonia, tuberculosis. These type of diseases it will find. So this is the overall system architecture. You do once you are purchasing a project means you will get the flow diagram, class diagram, everything. So proposed system, as I mentioned earlier, it will use GTCC STFT features. Those features are used to find out easily. Then this is the models of the project. There is a 4 type of modules: pre-processing module, data augmentation module, feature extraction module, In classification training model, CNN-LSTM. Feature extraction, we do recommend the sampling as well as noise reduction and all. Then data augmentation, we have to enhance the overall data set size. Then what we are going to do means feature extraction. We have to apply GTCC and STFC feature extractor to extract the mail spectrogram. From CNN LSTM network, we have to classify into various diseases. We have to train and classify the various diseases. Okay, this is the models. The main advantage was the proposed system uses less resources. You need a very low type of system itself to run this project. It was very complex process as well as we are using deep learning for better performance here. So overall CNN accuracy was very much higher when compared to the existing base paper accuracy. Okay. Then application also given, it can be used under various lung type of disease identification as well as you can implement this with a wearable devices also, smartwatch, something like that. After we are going to use Python for this Anaconda ID. In conclusion, we are given that CNN and LSTM will give the better performance when compared to the existing system. This system will be used for the very much helpful for the health industry. Okay, the reference of the project also given here. So this is the overall project PPT explanation. Now I am going to run the project for the execution. So this is the project code we have used for the training purpose. So these are the libraries we are going to use. We are simply going to use LibRosa library for audio processing. Mainly we are using LibRosa library for audio processing. This is the data set which you are going to use. Okay, CSV data set for the patient data. So you can find various disease data, URTI, healthy, asthma, COPD. These are the data we are using. Then how much crackles data and wheezes data, wheezing, crackle sound we are using. Those are the data we are going to use. Then you can find the overall how much data belongs to male, how much data belongs to female categories. This is the sample sound data. It will look like, okay, in PPT we explained now, it will look like this only, the audio data. So this is the audio data. It will look like that only. Once you are giving the audio data means it will look like this only as a frequency. So this is the overall data set graphs, how much data we are using, data set graphs we are going to use. Then the overall accuracy will be, this is the overall algorithm we are going to use. Then accuracy I will show. We got around 98% accuracy. So you can find 98% accuracy, which is higher than the base paper which we are using, So we got 98% nearly accuracy. So this is the project training model, overall training model. Now I'm going to run the project website for you. So this is the project website code. So I'm going to run the website for you to run. After copying the project location, I'm going to open Anaconda Navigator. In the Anaconda Navigator, I'm just opening the project environment here. So this is the project environment we have created. Here, we have installed many libraries to run the project. Just I'm opening terminal of the environment. So after opening the terminal, what I'm going to do means I'm going to paste the project location using cd space project location, then give enter. I'm going to run app py. This is the project code I'm going to run. Okay, app.py. So to run this, I'm going to type Python space app.py. This is the project I'm going to run. Just give enter. It will run the project specifically. So you have to wait for the project to compile. So this is the code I'm going to use, app.py. Here also I'm going to use LibRosa library. Then I'm just waiting for the project to compile. Once project compiled means it will generate the specific website for this. So we do check the various sounds and classification from the website. So once project compiled means it will just copying the project location. Just I'm pasting on the browser. After completion, after execution, you just need to copy the execution website link. Just you have to paste it on the browser. That's it. Once you have pasted means you do get the home page. This is the project home page. You can find the project title. You can find the project abstract also in the home page. The project abstract, which is mentioned about the LSTM and CNN. Just to go to the login page. So this is the login page. You can use admin as a username and password. Admin as a username and password. Just give login. Once login success means it will go for the main page. In the main page, you can give the patient name and patient lung sound for the identification purpose. Before that, what I'm going to do means I'm going to give the model. So this is the model page. In model page, we have compared various algorithms, logistic regression, recurrent neural network, then LSTM CNN. So you to get better accuracy in LSTM CNN. In the base paper they have used the lightweight inception network, so which will give the accuracy around 96.50 percentage, but in our proposed system you do get 98 percentage, which is very much accurate when compared to the existing system. So now I am going for the prediction page. In the prediction page you can upload any lung sound and you can check. So this is the prediction page. I'm just giving patient name as a Kumar, so I'm going to give patient name as a Kumar. I'm going to use lung sound. So to detect the lung sound, I given various test lung sounds also. You can use your own, not an issue. You can use your own images also. For example, I'm just using this sound. Example. So just I'm playing with the media player, that sound. So this is the sound I'm going to use now. Just a minute. Do means you have to select the signal sound. Just give the patient name. Just upload the sound signal. Just go to the project folder. Just select the sound. Just select and upload the sound. That's it. Once you upload it means it will go for the testing page. It will give the tested result. Okay. You do get the result page. So this is the project result page. This is the sound you uploaded. So this is the sound you uploaded. So this is the wave format of that sound. This is the extracted features of the sound. This is the feature we extracted from the sound. Then you can find the result. The respiratory disorder for this sound was pneumonia. We found the sound signal contains pneumonia symptoms. So the overall accuracy of the signal belongs to pneumonia category was 92%. So this signal belongs to pneumonia. So 92% it will shoot. You can download the patient report also. Just click this button. You can find a report also. So this is the overall report of this patient. Okay, sound signal, then wave format, then it will give the extracted results, then overall result of the disease name. Everything you can find here. Okay, just cancel this. Now I'm going to check with the another patient. To check with another patient, I'm going to for the analysis stage again. So not analysis, prediction stage I'm going. The prediction, now I'm going to give the patient name as a Madan. I'm going to choose different files now. I'm going to upload different file name. So different sound, just I'm using same detection button here. So after detection, you can find the result here. So you can see this is the signal you uploaded. So this is the audio format, wave format. This is the extracted features. The respiratory disorder detected was probability of COPD, coronary lung infection. The overall accuracy was 99%. Same, you can download the patient report also. Just download patient report. You can download the patient report also. Okay. So all the things you can download here. So now I'm going to check with another patient. To check with another patient, I'm just giving patient name as a Ramesh. Just choosing another sound file now. I'm using another sound here. Just upload this one. So after uploading, you can find the results. So this is the signal you uploaded. This is the extracted features that Librosa MFCC features, milfectogram features. The overall result was COPD 100%. So again, I'm uploading another patients. To detect another patient, I'm uploading one more signal. This time I'm giving patient name as a RAM. So I'm going to choose different file now. Different file I'm choosing now. Just give detect. It will give the detector results now. So same pneumonia category, probability was 92%. So you can check with any sound files, not an issue. It will work with all the sound files. Okay, your things also you can give. Now I'm giving patient name as a Henry. Just choosing one more signal now. Just give upload. So once uploaded means it will detect the results. COPD possibility 100%. Like that, it will work for the each and every signal. Okay. Then what you are going to go into for the precaution page. In precaution page, you can find how to avoid this type of diseases. We are given various exercise. Exercise means lifestyles to prevent this diseases. Okay, we are given various things here. You can check those things also. Then you go for the analysis page. Mean in analysis page, you can check the accuracy of this project. How much data set we have taken. You can find all the details here. So overall we have taken how much male category, how much female categories. Then overall accuracy of the project was 98% in proposed system. Okay, so you to get that also. Okay, you to get overall accuracy percentage. You can check the results also here in our trained result page. You can check the overall results. So this is the overall accuracy. You to get nearly 98% accuracy. So this is the project which you had discussed today. To get this project, please contact ieexpert.com. We do give this project at best price. Okay. You do get complete documentation, installation support, as well as a presentation, everything along with the project. Modification supports also we do provide. Okay. To follow more project details and that, please subscribe to our YouTube channel. Okay. Thank you.